Hi there, Johnny here. Hope you're doing alright. In this video we're going to go over how to set up a WireGuard VPN server on OpnSense. I just want to quickly go over my setup. So on the left here we've got the home/office, so this is where we'll have the OpnSense and we'll set up the WireGuard VPN service. And then the public IP is there, so 168.10.10.3. I've also just changed the dashboard widget, so I've removed everything and then I've just added the WireGuard widget just so that it's quick and easy for us to see if it's working or not. I've structured this video into, I'd say, two main parts. So the first part is setting up the instance and then just doing it so that you can follow the guide and you should be up and running as quick as possible. Then in the second half I've added client setup, so just so you can see how to set up it on Windows, Android and iOS. And then after that I've done a bonus section where I show you a bit more on DNS, DNS blocklists and then overrides, and then also just a quick example of split tunnel versus full tunnel. Yeah, let's get on to installing and setting up the instance. Yeah, so step one, we're going to create the WireGuard instance. So under the VPN menu, we'll click on WireGuard and then instances. Once that is open, we'll click on the plus button to add a new instance. So we'll give it a name. So in this case, I'm just going to call it WG-server. Then for the public and private key, you can just click on the gear icon to generate a new one. Now for the listening ports, the default is 51820. Now if you are running any other WireGuard instance or you want to change this, so for example add it to 1, 2, 3 or any one that you want that isn't in use. So in this tutorial I'll do 51821. Next is tunnel addresses. Now tunnel address, you must also use an address range that you're not using anywhere else. So I like to use something in the 172 range where I know it's not commonly used anywhere else. And that is it. You can click the save button. And lastly, click on the enable WireGuard checkbox and then click on the apply button. Step 2 is to assign the WireGuard interface. So now that we have an instance, if we go under interfaces, assignments, and under the device list, we should now see a WireGuard interface. You can select that and then click add and save it. This will now give us a new interface option on the left. Once you click on it, we can then enable the interface. And if you want to lock it, you can, but it's not really needed. You can save and apply those changes. Step 3 is to set up some firewall rules. So we'll go to the firewall menu, click on rules, and you'll see there'll be two WireGuard rule sets. So the group one, whatever you assign in here, will apply to any WireGuard instance. So you can think of it as like a universal one. Yeah, so if we click on the WAN rule set and then click on the add button. So the first rule we're going to create is to allow the WireGuard into the WAN. So for the interface, leave it as WAN, direction in, and then protocol is UDP. For the destination, you're going to change it to the WAN address. And then for the destination range, change it to other, and then you must put in the port that you use to create the instance. So in this case we did the 51821. I'm going to log the package just for troubleshooting purposes, and then I'll give it a description, WG-in. From there we can save it. The next rules that you want to create is for the WireGuard instance itself, or the tunnel. So usually you want to only allow specific things through. So example, if you only want DNS, HTTP, HTTPS, etc., you'll only allow those in. But just for this tutorial, I'm just going to allow anything through just to make it easier to follow. So I'm just going to create one that allows all through. I'm going to log it and then just call it allow all. Once we have got that, we can apply the firewall rules. The next step is to create the NAT Outbound Rule. So this allows the user internet access through WireGuard itself. So if you are using a full tunnel setup, the user will still have internet access. So under the Firewall NAT Outbound menu, we need to change it to hybrid mode and then click Save. Once saved, we will create a new rule. So for the interface, we'll keep it as WAN. For TCP IP version, I'll leave it at IPv4, and for protocol, we'll leave it as any. For the source address, we'll set it to WireGuard Server Network, so our instance network. We'll log it, and then I'll give it a description. So in this case, I'm going to call it WireGuard out NAT. You can save that. And once that is there, we can apply it. Step 5 is to normalize the traffic going through the WireGuard instance. So if we go under the settings and we go to normalization, what we'll do is create a new rule. So for the interface, we're going to choose the WireGuard group, or you can choose the WireGuard server. So in this case, we'll use the WireGuard group so that any WireGuard instance you create in the future will also use this rule. We'll leave everything as is, and we'll just go down to the description and we'll give it a description. So if you go to the WireGuard documentations, they give you the correct values that you should use here. So if you're using PPPoE or IPv6, whatever it is there. So just make sure to check that you're using the value depending on your setup. So in my case, I'll be using 1380. You can then save and apply the changes. Step 6 is to create your peers. So if we go back to the WireGuard settings, what I want to do before we create a peer, just under instances, let's just quickly restart the instance. So we'll just disable and then enable WireGuard, just so that if there's anything that hasn't been applied, it will be applied. We can then go to the peer generator, and this is where we can generate new peers. So what we need to do is get an IP address for our WAN or public IP. So in this case, our endpoint will be the 168.10.10.3, and then you have to put the port that you're going to use. So in this case, we've got it as 51821. If you're using a DNS name, you can use that instead, but you still have to put the port number at the end. For this, I'm going to call it Win11, because I'll show you how to set up a client on Windows 11. You can also give it a pre-shared key if you want. You can create your own or generate one. However, just note that pre-shared keys don't work on all devices. So for example, some Android devices. So in this case, I'm just going to leave the pre-shared key blank. For this tutorial, I'm just going to show you how to do a full tunnel. So that means once the client is connected to the WireGuard instance, all traffic will be directed or routed through the WireGuard instance. For this tutorial, I want to use Unbound DNS as the DNS server. So since Unbound is obviously on this OpnSense instance, I'm going to use the IP address of it, so 192.168.1.1. So later on in the bonus section, I'll show you how to change the settings to allow if you just want a split tunnel instance. You can also set a keep alive interval, so for example 25, but you don't have to, you can leave it blank. Once you're happy with your settings, I'm just going to save it to a text file so that it's easier to copy it to the Windows machine that we're going to use it on. Once you have it saved, you can apply the peer. If we go back to the instance now and we click on the edit icon, we should see the peer pop up. Once it is there, we need to just reapply or restart the WireGuard instance for the peer to apply. Step 7 is to set up the WireGuard client on the devices. So for our first example, I'm going to show you how to do it on a Windows 11 machine. We can just search for WireGuard. Then on their website, so it's wireguard.com, under installation you'll find all the setup files. So I'm going to download it and install it. Once it's installed, open WireGuard up, click the little arrow next to the add tunnel and choose the add empty tunnel option. I'm going to give it a name, so in this case I'll call it Home Office, and then I'm just going to copy those settings we got from the peer generator and paste it in here. Since I'm not going to be using RP version 6, you can remove that. The client also has a function to set up a kill switch. So if you're using full tunnel, it will allow you to enable or disable this option. So I'll just leave it enabled. Once saved, we can click on the activate button, and if everything's successful, you should start seeing both send and receive packets and data going through. If we go back to our OpnSense instance, under stats you should start seeing the client is connected, and then also if we go to our dashboard widget, we should see as well that our Windows 11 client is connected, and you can see the data that's going in and out. If we also go to the live view of the firewall, you should also start seeing traffic coming from the tunnel. And the NAT rule, if you see that the data is going through the NAT rule, as you can see from our VM, we still have internet access through the WireGuard instance. So in this case, you can see the HTTPS traffic going through. I just want to quickly let you know that I recorded this earlier in the year, and then I got busy, so I couldn't carry on. However, when I went back to complete this tutorial, I wasn't happy with the recordings. So you'll see that the iOS and Android setup section is using different details, so example endpoints, than the main tutorial. However, the process is the same, so you can just follow these steps, but just obviously change the details to suit yours. I also want to let you know that when I first recorded this tutorial, I did Blocklists in the beginning. So you'll see I added facebook.com to a block list. So when I test them on the phones to see if the traffic is going through the instance, you'll see that when I go to Facebook, it does not pop up since it's blocked. On this tutorial, if you go to the bonus sections, I've got DNS blocklist section where you can then go and see how I done the blocklist. The process of adding WireGuard on a mobile phone is pretty simple. So all you need to do is generate your peer, so you put in your desired settings. Once done, you download the WireGuard client app. Then using the scan QR code option, you will scan the QR code. Once it has been scanned, only then do you click on the store and generate button. Then you can just make sure to add it as a peer. You can then just reapply the WireGuard instance settings. Once it is applied, you can then return to your phone, activate the VPN, and you should be connected. So now if we test it, we should still have internet, and since I have Facebook on a block list, if we try access Facebook, it should be blocked. Okay, to set it up on Android, it's the same procedure. So first we'll go to peer generator, fill in the details that you want. Just as an example, I'm going to show you what happens if you used a pre-shared key on an Android device. So I'm going to generate one. But once all the settings are in there and you're happy, you can then go to your App Store again. So in this case it's Google Play Store, and then you can download and install the WireGuard app again. Once it's installed, you can click on the plus and then scan the QR code. Now if you use a pre-shared key and you try to scan it in, you'll see it says that it's an unknown configuration file. It is not happy. So what you need to do is just go back to your peer generator and make sure you remove the pre-shared key. Now when you scan, it will accept the configurations and you can save it. Once saved, you can go back to OpnSense, apply it, make sure it is showing on the WireGuard instance, and then just apply the WireGuard settings. On your phone, you can then go back and enable the WireGuard connection. While I was doing it, I saw that I put in the wrong DNS settings, so I'm just going to quickly fix that. So on the app, I'm going to change it to 192.168.1.1. And then I'm going to save that, and then we should be good to go. So now if we go back to our browser, we should still have internet access. And if we try to go to facebook.com, it should block us since it's on a block list. So if you do decide to use Unbound as your DNS server, the beauty of it is that Blocklists will still work. So if you see my settings under Unbound DNS for query forwarding, I'm just forwarding all queries to Google. And then for the Blocklist, I've got it enabled. And then two examples we'll use. For example, I'll block facebook.com and apple.com. So if we go to our Windows 11 virtual machine again, and then we go to apple.com, you'll see that it is blocked. So we know the block lists are working. I also just recommend, if you go back to the block list, you should rather put all of the domains under the wildcard domains. In that way it will block any wildcard off of that domain. And then just as a final check, if we remove Apple, and then we'll clear the DNS on Windows 11, then if we ping Apple again, for example, you'll see we get the correct IP back. So if we go to the website, we should have access to it again, which we do. I've sped this part up quite a lot, but just as a reminder, if you want to force all DNS, so non-encrypted DNS traffic to Unbound, you will still need to go and create a port forwarding rule to redirect that traffic to Unbound. So I'm not going to go over that in detail in this video, but I have created a video in the past about DNS, Unbound DNS and the Blocklists. So in that video I'll go over the port forwarding and then the firewall rules. So in this sped up section of video, you'll see I use Facebook as an example. So if we Google Facebook and it does its DNS check, you can see that it does get redirected. So we know that all DNS is getting forwarded to Unbound. Now if we just double check that the blocklist is working again, so for example we'll go to DNS lookup diagnostics and we do facebook.com, you'll see that it returns 0000, so we know for a fact that it is getting blocked. So for example, if we go to facebook.com, Firefox adds www to it, which obviously resolves. But if we go to facebook.com, you'll see it does not resolve. So as I mentioned earlier, is what we actually want to rather do in our Unbound blocklist is just make sure that we move facebook.com from the blocklist domains to the wildcard domains. So that way it will also block the www and so on and so forth. Now if we go back to our Windows machine, let's see, it should hopefully block it. The next nice thing about using Unbound DNS is you can use DNS overrides. So on this Ubuntu machine that we've been using, I've created a Samba share folder, and then what we'll do is under the override menu under Unbound DNS, we're going to create a domain for this Ubuntu virtual machine. So what I'm going to do is just go into the settings and let's see what IP address this machine has. So it's 192.168.1.101. So I'm going to create a new host override. Okay, so first we'll start off with the IP address. So I'm going to put the 192.168.1.101. Then for the host, we'll call it whatever we want. So I'll call it my server, and then for the domain I'll put here DNS. Once we have that, we can save and apply it. Then I'm just going to go into the general section of Unbound and just also apply, save it and apply there. Now if we go back to our Windows 11 virtual machine and we ping that name we just created, so myserver.dns, since we connected we should get pinged back, and as you can see we get the correct details back. We can then confirm the override by deactivating the VPN. So now if we try ping the server again using the domain name, we shouldn't get any response. So there we don't get a response. But if we activate the VPN again and we try again, we should now get a response. So we know the override is definitely working. So now what we can do is, since we know the override is working, we can then access that machine's shared folders by simply putting in that domain, so myserver.dns, put in the username and password, and then we should have access to the machine. So the last thing I just want to quickly go over is just showing you an example of split tunnel versus full tunnel. So you can see at the moment we're doing what is called a full tunnel, so we're using 0.0.0.0. So in other words, all traffic will get routed through the VPN. However, if we just want traffic to access specific servers, so for example the 192.168.1.101, so the Ubuntu machine, we can just put that in there. Now if we test it, for example, we'll try ping it. We should get a response back. Now if we go to a web browser and we access the internet, you'll see, for example, like Facebook is still working. So that means that web traffic is not going through the VPN anymore. It is going directly through the router, or the device's network itself. So for example, if we try ping that override we did, the myserver.jns, you'll see it does not work because we haven't told WireGuard to route that traffic through as well. So if we want to use split tunnel and use the DNS as well on our OpnSense instance, we need to put that IP under the allowed IPs as well. So 192.168.1.1. So now if we save that and we test it again, so we'll ping it, you should see we now get a response back. So now this is how you can use split tunnel to access only specific servers, for example, and then still use your Unbound DNS. And then any other traffic, so web traffic and all of that, will still go through the user's device itself. So again, if we go now, try reload Facebook, you'll see it's blocked. You can also see if we set it back to being a full tunnel, so 0.0.0.0, you'll also notice that the kill switch option is available again, whereas obviously in a split tunnel option that is not available. So if this video helped you, please consider liking and subscribing. I would appreciate it. And until then, I'll see you in the next one.